So now the next property you are going to learn is the convolution property of Laplace transform. Okay, convolution property. So here it states that if the Laplace transform of x1 of t is equal to x1 of s and the Laplace transform of x2 of t is equal to x2 of s, then the Laplace transform of x1 of t convolution with x2 of t, x1 of t convolution with x2 of t is nothing but x1 of s into x2 of s, where x1 of s is the Laplace transform of x1 of t and x2 of s is the Laplace transform of x2 of t. That means what this property actually means is that convolution in time domain is equivalent to multiplication in frequency domain. Or in other words, suppose if you want to find the convolution of two signals, okay, if suppose you want to find the convolution of two signals, you know the equation for convolution, right? If x of t and h of t are the signals, then the convolution is integral from minus infinity to plus infinity x of tau h of t minus tau d tau, right? So this is the convolution formula. So if you want to find the convolution of two signals in time domain, you need not apply the direct equation. What is more easier than that is all you need to do is find the Laplace transform of the individual signals. Find the Laplace transform of the individual signals and simply multiply the Laplace transform of both the signals. That is the frequency domain of the convolution. That is multiplication in time domain, convolution in time domain is equivalent to multiplication in frequency domain. Okay, so now let's prove this theorem. We know that this is x1 of t convolution with x2 of t. So we know the equation. The equation is integral minus infinity to plus infinity x1 of tau into x2 of t minus tau d tau. Okay, but since these two are causal signals means right-sided signals. Only on the right side. That means this signal exists only on the right side. That means on the left side is 0. That means from minus infinity to 0, these two values are 0. That's why the integral starts from 0 to infinity. Okay, 0 to infinity. So integral 0 to infinity x1 of tau x2 of t minus tau d tau, where tau is the dummy variable. This is the equation of convolution. Okay, so now what I'm going to do is I'm going to apply Laplace transform to this equation. I'm going to apply Laplace transform to this equation. So the Laplace transform of x1 of t convolution with x2 of t is equal to integral from 0 to infinity. Okay, this is a unilateral Laplace transform. So integral 0 to infinity. So this is I want to find the Laplace transform of this. So this comes into the equation. Okay, x1 of t convolution with x2 of t. Okay, into e raised to minus st dt. This is the Laplace transform of this. This is the Laplace transform of this. Okay, so now what I'm going to do is I'm going to substitute this equation over here. Okay, we know what is x1 of t convolution with x2 of t. It is this one. So this I will substitute over here. So I will get integral 0 to infinity into integral 0 to infinity, this one. Okay, x1 of tau x2 of t minus tau d tau. Okay, into remaining e raised to minus st dt. Okay, so now what I'm going to do is I'm going to express t minus tau as another variable. Okay, so let p is equal to t minus tau. Okay, so if p is equal to t minus tau, then that means if I differentiating it, dp becomes equal to dt because tau is a constant. So dp is equal to dt. Okay, so what I'm going to do is I'm going to replace t minus tau with p, then I'm going to replace dt with dp, then I'm going to replace this t with p plus tau. Okay, I'm going to replace t with p plus tau. So my next equation becomes integral 0 to infinity into integral 0 to infinity x1 of tau. So x2 of t minus tau becomes x2 of p d tau into e raised to minus s. T is replaced with p plus tau. T is replaced with p plus tau. So e raised to minus s into p plus tau dp. Okay, so now what I'm going to do is I'm going to separate this to exponential equation, this to exponential function. Okay, so this will become integral 0 to infinity into integral 0 to infinity x1 of tau into x2 of p into d tau into e raised to minus sp into e raised to minus s tau dp. Okay, so this equation is basically an integration of two variables. One is of p and the other one is tau. One integration is with respect to p and the other integration is with respect to tau. So what I'm going to do is I'm going to separate those two integrations. If you can see here in this equation, this integration is with respect to only with tau. So that means as far as x2 of p is concerned, x2 of p is a constant. So I can take x2 of p outside. Okay, and likewise, since this is an integration with respect to d tau, then this e raised to minus s tau can be taken inside, right? So this term can be taken outside and this term can be taken inside, because this is also has a tau inside. So since this is an integration with respect to tau, I can take this term also inside, and this is a constant. As long as this integration is concerned, this term is a constant, so I can take this constant outside. So the equation becomes, so this equation becomes integral 0 to infinity x2 of p into integral 0 to infinity x1 of tau into e raised to minus s tau d tau into e raised to minus sp dp. Okay, so we all know what is this, right? We all know what is this. Considering that tau is another variable like t, then this is nothing but the Laplace transform of x1 of s. Right, the equation for x1 of s is integral 0 to infinity x1 of t into e raised to minus st dt. But here t is replaced with tau uniquely. See, as far as mathematics is concerned, tau is another variable like t, right? So integral 0 to infinity x1 of tau into e raised to minus s tau d tau is also x1 of s. Okay, so this becomes, so this entire equation becomes x1 of s. So you will get integral 0 to infinity x2 of p into x1 of s into e raised to minus sp dp. Okay, so now this integration is basically with respect to p. Therefore this x1 of s can be treated as a constant, so I will take it outside. So this will become integral 0 to infinity x2 of p e raised to minus sp dp. Okay, this is also another Laplace transform, okay, in which this is a function of p, right? This is nothing but integral 0 to infinity x2 of t into e raised to minus st dt. But as t and p is concerned, they both are nothing but variables in mathematics, right? So this is also a Laplace transform called as x2 of s. So you will get x1 of s into x2 of s. Therefore the Laplace transform of x1 of t, convolution of x2 of t, is nothing but x1 of s into x2 of s, which means that, you know, the quicker way of finding the convolution is simply, instead of applying the convolution equation, it is better you find the Laplace transform of the individual functions and then you simply multiply these two functions. Okay, now let's do this problem. Given x1 of t is equal to e raised to minus 2t u of t and x2 of t is equal to e raised to minus 3t u of t. Find the Laplace transform of the signal y of t, where y of t is nothing but x1 of t minus 2 convolution with x2 of minus t plus 3. Okay, so now we know that we have to apply convolution property in this equation. Okay, so what you have to do from here, you have to find the Laplace transform of this signal. So the only way to find the Laplace transform of this signal is find the Laplace transform of this, then after that you should find the Laplace transform of this, then you multiply these two Laplace transform. That's it, that's the answer. That's how you find the Laplace transform of this. Okay, so here x1 of s is equal to Laplace transform of x1 of t minus 2. Okay, and x2 of s is equal to the Laplace transform of x2 of minus t plus 3. Okay, therefore the Laplace transform of y of t is nothing but x1 of s into x2 of s. So you need to find only the Laplace transform of these two answers, then substitute in this equation. Okay, so first we find x1 of s. First we find the Laplace transform of this. Okay, so here, so given x1 of t is equal to e raised to minus 2t u of t, right? So therefore the Laplace transform of x1 of t is equal to 1 by s plus 2, right? 1 by s plus 2. Okay, so this is 1 by s plus 2. So therefore x1 of s is equal to the Laplace transform of x1 of t minus 2, which is nothing but you need to apply the time shifting property to this equation. So this is minus 2, right? So the time shifting property, if you apply this, it will become e raised to minus 2s into 1 by s plus 2. E raised to minus 2s by s plus 2. Okay, this is x1 of s. Now you need to find the x2 of t, x2 of s. Okay, so here now x2 of t is nothing but e raised to minus 3t u of t. Okay, so therefore the Laplace transform of x2 of t is nothing but 1 by s plus 3, right? So therefore x2 of s, the second Laplace transform, x2 of s is equal to the Laplace transform of x2 of minus t plus 3. Okay, so in order to find the Laplace transform of this, here we have to understand what is the scalar quantity and what is the shifting quantity. Okay, scalar quantity and the shifting quantity. So I am going to make a small change over here, a very small change. Laplace transform of x2 of, I am going to take minus 1 common, so minus 1 into t minus 3. Okay, so now I know that the scalar quantity is minus 1 and time shifting quantity is time shifting value is minus 3. Okay, so in that case, first I will apply time scaling, then I will apply time shifting. Very simple. So here Laplace transform of x2 of t is equal to 1 by s plus 3, right? So therefore if I want to find its scalar quantity, then this will become, that means Laplace transform of x2 of minus 1 into t, right, or minus t is equal to 1 by mod of minus 1 into x of s by minus 1. Okay, mod of minus 1 is 1 itself, so this is nothing but x of minus s, which is nothing but 1 by, replace this s with minus s, so it becomes minus s plus 3. Okay, or is also equal to 1 by 3 minus s. This is the Laplace transform of t of minus t. This is the Laplace transform of x2 of minus t. Okay, this is the Laplace transform of x2 of minus t. Now I am going to find the Laplace transform of x2 of minus t minus 3. Minus t plus 3. That's why I'm going. That's the meaning of this term. That is, I'm going to shift the value by minus 3. So I'm going to apply time shifting. Now I already applied time scaling property. Now I'm going to apply time shifting property. So this will become e raised to minus 3s by 3 minus s. Okay, this is this thing is this one. Okay, so x2 of s, I have found x2 of s, which is nothing but e raised to minus 3s by 3 minus s. So therefore the Laplace transform of the given question is x1 of s into x2 of s, which is nothing but x1 of s is e raised to minus 2s by s plus 2 into, and x2 of s is e raised to minus 3s by 3 minus s. So therefore this is your answer. If I am multiplying these two, it will be combined, so it will be e raised to minus 5s by s plus 2 into 3 minus s. This is your answer. Okay.